Ever feel like you're just drowning in a sea of generative AI jargon? Well, you've come to the right place. Today, we're going to cut right through all that noise. We found nine, yes, nine, really unique resources that are going to give you that aha moment and show you how these things actually work. Let's dive in. Okay, let's just get it out there. LLMs, GenAI, transformers, embeddings, RAG, the list of buzzwords just keeps growing, doesn't it? It can feel like a lot, but the whole point of this explainer is to give you a real intuitive feel for what's going on under the hood without all the confusing jargon. I think we've all been there, right? You want to learn, so you start opening tabs, articles, videos, tutorials. Pretty soon you have this huge collection of tabs you swear you'll get to, eventually. Well, today's the day we finally make sense of those tabs. We've taken that chaos and turned it into a clear path forward. So here's our game plan. We'll start by quickly decoding some of that key jargon. Then we'll explore 3 different ways to learn depending on what works for you. The big picture conceptual path, the gets your hands dirty hands-on path, and the wonderfully weird experimental path. And then we'll wrap up with a great way for you to get started. All right, first things first, let's get on the same page with the language. Honestly, if you can just nail these few key terms, everything else we're going to talk about will make so much more sense. Just think of this as your personal cheat sheet. So here's the key thing to remember. It's all about layers. GenAI is the big, broad umbrella term. An LLM, or large language model, is one type of GenAI. And GPT is an even more specific brand of LLM, you could say. It's just like saying food, then fruit, then apple. Simple as that. Okay, let's jump into our first learning path. This one's for everybody who wants to understand the how and the why behind all this, but without necessarily writing a single line of code. If you're a visual learner, a big picture person, this section is for you. Our first stop is a nearly 20,000-word article by the brilliant Stephen Wolfram. Now, I know what you're thinking, 20,000 words, but trust me, don't let that scare you. It might be the single most accessible, step-by-step explanation of how these models work from the ground up. And this quote right here, this is the beauty of his explanation. He takes this massively complex system and boils it all down to this one simple idea. At its very core, an LLM is basically a probability engine. It's just constantly asking, based on everything I've seen, what's the most likely word to come next? And it does that over and over and over again. Next up, if you're someone who really needs to see it to get it, you absolutely have to check out the YouTube channel 3 Blue 1 Brown. If Stephen Wolfram builds the idea with words, the creator, Grant Sanderson, builds it with these stunning animations. He literally makes math look like art. And this is where it just clicks. He doesn't just tell you about concepts like vectors or attention. No, he shows you these grids of numbers, the actual data, flowing and transforming right on the screen. He makes these abstract ideas feel totally concrete. It's no surprise people call his videos a work of art. And rounding out this path are 2 more amazing educators, Luis Serrano and Jay Alamar. Their shared superpower is making complicated things feel simple. Luis is all about giving you the intuition behind the math with really simple analogies. And Jay, his illustrations are legendary. They just walk you through how everything works step by step. All right, path number 2. It's time to roll up our sleeves. This one is for the builders, the tinkerers, anyone who hears all this and just thinks, okay, that's cool, but let me make something. If you learn by doing, this section is for you. And who better to learn from than a giant in the field? We're talking about Andrej Karpathy, one of the co-founders of OpenAI and the former head of AI at Tesla. In a single 2-hour video, he literally walks you through building a GPT, starting from a completely blank file. And this isn't just theory. Oh no, you're actually coding along with him in Python. You feed the model all of Shakespeare's plays, and by the end you have a working model that generates text that sounds like Shakespeare. It's such an empowering feeling, and it completely demystifies the whole process. Now, for a slightly different approach, there's Jay Modi's Pico GPT. Instead of building and training from scratch, this one focuses just on the core logic. And the incredible part? He shows you how to do it in just 60 lines of code. 60! It's an absolute masterclass in getting straight to the point. Now, for what might be my favorite section, the experimental path. The examples we're about to see are kind of weird, they're totally impractical, and they are absolutely brilliant. They prove that at the end of the day, a language model is just a series of math problems, and you can solve those problems in some very strange places. Yep, you read that correctly. A guy named Ishan Anand managed to build and run the entire GPT-2 model inside Microsoft Excel. It's just this wonderfully audacious project that breaks down all the complex math into steps you can literally see inside the spreadsheet cells. And this isn't your average budget spreadsheet, let me tell you. The file itself is a massive 1.25 gigabytes. That number alone just gives you this gut-level sense of the sheer scale of these things, even a model like GPT-2 that's a few years old now. And if you thought that was wild, another creator went and implemented GPT-2 using nothing but SQL. And here's the best part of the story. He actually asked ChatGPT if it was even possible first, and ChatGPT told him no. So, naturally, he went and did it anyway. So how on earth did he pull that off? It all comes down to this one simple, crucial insight. These models aren't magic. They are just deterministic math. That means if you give it the same input, it will always give you the exact same output. It's predictable. And that means if your programming language can do math, you can probably build a GPT in it. But, just because you can do something doesn't mean it's a good idea. To generate just 10 words, his SQL model took almost 3 minutes. So yeah, wildly impractical. But what an unforgettable lesson in how these models actually work, right? Okay, we have covered a ton of ground, from big ideas to crazy experiments. So you're probably wondering, where should I actually start? Well, if you're ready to get practical and start applying this stuff to real-world projects, we've got a fantastic first step for you. There's a course on Scrimba that's a perfect entry point. It doesn't get bogged down in all the deep theory, it just jumps right into building things. You'll learn really useful skills like RAG, that's how you get an AI to use your own custom documents, and embeddings, which is how an AI understands the meaning of words. And best of all, you can code and experiment right there in your browser. It's a great hands-on way to start. And that brings us to one last thought to leave you with. Every single resource we talked about today, Wolfram's writing, Karpathy's video, Sanderson's animations, they were all crafted by a passionate human being who wanted to explain something clearly. As AI gets better and better at just generating content, it makes these incredible feats of human explanation feel even more valuable, doesn't it? So the question is, how do we protect that art? Just something to think about. Thanks for tuning in.